Hi guys, so in this video, I'm going to show you some examples of how we solve equations using the steps that we talked about, the three-step process for solving equations. So when we combine our like terms, getting rid of our constants, getting rid of our coefficients, and I'm also going to model all of these properties of equality that we talked about as well. So here is a couple of equations, or the equations that I'm going to demonstrate in this video. If you want to take a moment to pause the video so you can write all of the equations down on your paper, go ahead and take a moment to pause the video and write all of the equations down on your paper, and then start the video back up again when you're ready to see how we're going to solve them. Okay, so you'll notice in the first four problems that these are what are called one-step equations. It is only going to take me one step to solve and figure out what the value of our variable is going to be in these equations, okay? The ones a little farther down, you'll notice we have some coefficients, some constants. These are a little bit more in depth. We call these multi-step equations. So it's going to take us more than just one step to solve the equation. So let's look at the first couple of equations. So the first one says x minus 7 equals 21. So this is saying some number minus 7 equals 21. And your goal is to figure out what this number is. What is the value of x when we subtract it from 7? It equals 21. So the first step is we look at our equation and we see if there's any like terms that we can combine. And there are no like terms that we can combine. So we can move on to step 2, which is getting rid of our constant. So our constant is 7. And the way that we're going to get rid of it, okay, remember the goal is we're trying to figure out what x is equal to. We are trying to figure out what x is equivalent to. We're trying to get x by itself on one side of the equation. And we're going to use those properties of equality to kind of undo what's happening here. So if 7 is our constant, 7 is being subtracted. So that means I'm going to use the inverse operation, or the opposite of subtraction, to figure out what x is equal to. So the opposite of subtraction is add. I need to add 21 and 7 to figure out what x is equal to. And I'm going to use that addition property of equality, APOE, APO, if you want to call it that, to figure out what x is equal to. So if I do this, essentially what I'm doing is I'm removing the 7 from this side of the equation. Negative 7 plus 7 would just be 0. So we have x by itself now. And on the other side of the equation, 21 plus 7 is 28. So by doing the same thing to both sides of the equation, I isolated my variable and I got x is equal to 28. And the nice thing about equations is I can go back and solve. Like I can plug in 28 for x and make sure that I'm correct. So if I do that, if I go back and plug it in, 28 minus 7, I'm checking to see if I get 21. And yes, I do. 28 minus 7 is 21. So you'll see, we just did one step. We just added 7 to both sides of the equation to figure out what the value of our variable is. This is a one-step equation. Let's look at the second one. This says 15 plus x equals negative 30. So the first thing I'm going to do if I follow the three-step process is combine any like terms. I don't have any like terms that I need to combine. This is a constant. This is a variable on its own. So the next thing I'm going to do is I'm going to get rid of my constants. So my constant in this particular equation is 15. And this is a positive 15. There's no negative sign attached to it. So the way that I'm going to get rid of it is I'm going to do the opposite. And if it helps you, you can write the plus sign here. I'm going to do the opposite of adding. I'm going to subtract this 15 from both sides of the equation. I'm using the subtraction property of equality to figure out what the value of x is. Because I know 15 plus some number x is going to get me a negative 30. And I'm trying to figure out what x is equal to. So if I do this, if I take away 15, I am just left with x by itself, because I could put 0 plus x, but 0 plus x is just going to be x. This is equivalent to, I'll write it out like this, 30 minus 15. I'm sorry, negative 30 minus 15. So if I do this subtraction, I get x is going to be equivalent to negative 45. Negative 30 minus 15, we go farther in the negatives, so x is negative 45. So I have isolated my variable. I use the subtraction property of equality to figure out what x is equal to. I can go back and plug it in. 15 plus negative 45. I'm checking to see if I get negative 30. And the answer is yes, I do. This is the same thing as like 45 minus 15, but we're still in the negatives. We keep the absolute value of the number that has, or we keep the sign of the number that has the biggest absolute value. Negative 45 is the farthest away from 0, so we keep the negative sign. So this is an example of subtraction property of equality. Okay. These next two, we're going to use the multiplication and division property of equality. So this equation right here is telling us 4 times some number x is equal to negative 100. So if you take a moment, think about it. If 4 is being multiplied by x, okay, I don't have any like terms. I don't have any constants that I need to get rid of. So according to the 3-step process, I need to get rid of the coefficient now. So I'm going to get rid of the coefficient 4 by doing the opposite kind of math, the inverse operation of what's being done. So what's being done is multiplication. So I'm going to divide, use the division property of equality to figure out what x is equivalent to. 4 divided by 4 is just 1, and 1x is the same as x. So x is going to be equivalent to negative 100 divided by 4. 4 goes into 100 25 times, and since it is a negative divided by a positive, our answer is negative 25. Okay, and I could go back in, plug in negative 25 here and solve and see that 4 times negative 25 gets me negative 100. I'm not going to write it down. You can if you want. But all we did here was the one step of division. We did the opposite, the inverse operation to figure out what x is equivalent to. Okay. So in this last one step equation, we are dividing. This is saying x, I can even write it like this if I want. X divided by 2 equals 25. So some number, when we take half of it, is 25. And we're trying to figure out what is this number. Okay, so I'm going to make sure I choose the appropriate property of equality. Since I am dividing, I'm going to use the inverse operation, do the opposite. I'm going to multiply both sides of my equation by 2 to get x by itself. So if I'm dividing by 2, but then I multiply by 2, like that cancels out. So this is x. 25 times 2 is 50. So x is equivalent to 50, and we use that multiplication property of equality. It's important that you're labeling your properties of equality so you know the steps that you have to take in certain problems. That's going to be part of your homework assignment, is labeling the property of equality. So make sure you're labeling it here on your notes with me. And if I go back and plug in x, 50 divided by 2 equals 25, because half of 50 is 25. Okay, now these last ones are going to require more than just one step. So we're going to have to either combine our like terms, get rid of constants, get rid of coefficients. There's more of that 3-step process that we're going to have to follow. So if I look at the first example over here, 4x plus 10 equals 50. So the first step is to combine any like terms. 4x and 10 are not like terms. So I cannot combine them in any sort of way. So I don't have to do anything with that. The next step is I want to get rid of my constant. Okay, this is our buddy. If we're thinking about revenge on this x, okay, the buddy is an easier person to sway and get rid of than our x's best friend. Okay, so I'm going to look at what kind of math is being done and choose the appropriate property of equality. So we're adding 10, which means to undo it, I am going to subtract 10 by using that subtraction property of equality. Subtract 10 from both sides of my equation, and I end up with 4x. When I subtract 10 over here, 10 minus 10 would just be 0. 50 minus 10 is going to be 40. So when I subtract from both sides, this is what I end up with. So I have gotten rid of my constant. Now all I have to get rid of is the best friend. So I'm going to look at the kind of math being done. 4x means to multiply. So the way that I'm going to undo it is I'm going to use the division property of equality. divide 4 from both sides of the equation. And so when I do this, 4 divided by 4 is just 1x, which is x by itself. 40 divided by 4 is 10. So x in this problem is equal to 10. And I can check by going back and plugging it into the equation. 4 times 10 plus 10, do I get 50? 4 times 10 is 40. 40 plus 10, it does equal 50. So x is equal to 10 in this particular problem. And you'll see I had to use 2 steps. I had to use my subtraction property of equality and then my division property of equality. Okay, let's look at the final one. This one, they threw a negative in here. We have negative 3x plus 1 equals 10. So I don't have any like terms that I need to combine. So I'm going to move on to getting rid of the constant, the second step. So since I am adding 1, I am going to use the subtraction property of equality to subtract 1 from both sides of my equation. So I am left with negative 3x is equivalent to 10 minus 1, which is 9. Now I'm going to look at the equation and I'm going to see what's happening. I want to get rid of my coefficient now. That's the third step. So multiplication is happening here. So negative 3 times x. So I am going to use the division property of equality to get rid of the negative 3, to get rid of that coefficient. So negative 3 divided by negative 3 is 1. 1x is just x. And 9 divided by negative 3, 9 divided by 3 is 3. But since one of them is positive and one of them is negative, my answer is negative 3. And again, I can go back and check my answer. So I can go back and plug in negative 3 times negative 3, since that's what I got for x, plus 1. I am checking to see, does this equal 10? Negative 3 times negative 3 is 9. 9 plus 1 equals 10, which is what the equation was set up as. And so in this case, again, I use the subtraction property of equality and then the division property of equality to figure out what x is equivalent to. So you'll notice we did the same thing to both sides of the equation in all of the problems. We labeled those properties of equality that we used, and we also used all the opposite or the inverse operations to essentially undo our equation to figure out what the value of x is equal to. Some of you, it may intuitively make sense, like when you looked at maybe this particular problem here, you could figure out pretty easily, oh, 28 minus 7 is 21, x is 28, okay? But really what you did in your head is you did this. You figured out, oh, hey, if I do the opposite, if I add 7 to 21, that's going to tell me what I'm like, what I need to subtract with. So you did the addition of you did the addition property of equality in your head. It's important to write out these steps because in our class, these multi-step ones will probably be like the hardest ones you see. But next year in 7th grade math or in algebra, there tends to be 4 or 5 steps. You have to use like 4 or 5 or 6 properties of equality. So it's important that you're understanding the process here. Okay, please go back and look at these examples if you have more questions. Go ahead and get started on your assignment.